Hi guys, hope you're having a good day. Got another little lesson about acids and bases for you today. So yesterday we had a bit of an intro about what is an acid and what is a base. And basically the answer to that question is an acid is something that has H plus particles, like this guy, and a base is going to have OH minus particles, or maybe it'll make OH minus particles. Yeah, so that's basically the difference between a base and an acid, simply. And today we're going to be looking at how you'll measure if something is basic or acidic. So there are a few ways to do this. One way is using litmus paper, which is this stuff here. And it's just paper that you put in a liquid. If it's acidic, it will go red. And if it's basic, it will turn blue. Really simple test if you're not colorblind. However, that can only tell you if it's basic or acidic. It doesn't tell you how much it is, how basic or acidic it is. What you can use to get a better idea is universal indicator, which is the stuff on the left here. I've got some of my own here. And basically what you do is you add it to water and it's going to change color. And on the back here, so the camera, it'll tell you what color it will change, and whatever color that is, it'll tell you what pH it is. My universal indicator here only goes from 9 to 4.5. So for indicators, you can only go 2 colors, and we'll look at those at school because you have a bit of a play at them. But for the universal indicator, it can go all of these colors from red to purple. Now, if it's pure water, or it's a pure non-acidic or non-alkali, non-basic liquid, it's going to go green. So with pure water, it should go green. Let's see. Here is some water from my tap, which I prepared earlier. And I'm going to put some universal indicator on, and we'll see what color it goes. If it's pure water, it should go that green in the middle for neutral. My water, well, no, it's from the rain. It's been sitting in my tank for a while, maybe, so who knows how pure it is. But after adding the indicator, it is this color, which, yeah, it's about, I reckon it's about 7. Let's compare it with this on the back. Yeah, I'll say that's 7. Oh, maybe 6, 7.5. Anyway, about 7.5. Oh, sorry, 7, between 7 and 8 there. So water is about neutral, which is good. Here I have some rice wine vinegar. I'm trying to find something from my fridge, from the pantry, that might change color. And as you can see, here it's colorless. And when I put it in here, add some universal indicator, it goes red. So turns out my vinegar is acidic. That's all right, I can still drink it. It's only slightly acidic. Where do you reckon that's up to? It's quite acidic, isn't it? My scale on my pH is different to your one on the computer. So mine says it's about 4.5. Anyway, so vinegar, definitely acidic. What else do I have? Let's try this one here. This is what I use to clean my floor, handy Andy all-purpose cleaner. This one's very thick. Cool. And actually I'll put some water with that. So I've just diluted it down a bit so it's a bit more of a liquid. It's not going to change the pH at all, I don't think. So before and after, when I add it, it goes purple. So if you look on your periodic table, your pH scale here, purple is very alkaline or basic. And last one I'm going to show you. I don't know if it's going to work that well, but we'll give it a go. I've got some milk from the fridge. White. See what colour it goes with a bunch of this. Oh, that's weird. Alright, it's probably going to need a lot more because the Alright. Well, the milk's gone slightly greener, I think. But it's mostly that white colour which is staying behind. So actually it doesn't really work that well with the milk because it's more, you can't really see the actual colour that's formed because the milk colour is stronger. But I'll tell you right now, milk is slightly acidic, apparently. It's got something called lactic acid in it, you may have heard of. So these colour changes can be used to measure the pH. And pH is the amount, is how acidic or alkaline something is. If it's 7, it's neutral. As it gets lower, which may confuse some people, it gets more acidic. So really acidic things have a pH of 1. As it gets more alkaline, it starts going purple. And it'll get to, the pH can go up to 14. We say the pH between 1 and 14. In exceptional circumstances, it can go outside of that range, but for now, we're just going to say 1 to 14. So here we go. Here's the pH scale again with some of the things that I measured. So milk, slightly acidic on this side. Vinegar, more acidic down here. Measured that. Bleach, that's the cleaner I used, ammonia bleach. Obviously quite alkaline. Stuff like stomach acid. So yeah, inside your stomach you've got hydrochloric acid, which breaks down the food, but obviously your stomach is strong enough to stop the acid from breaking the stomach down. But if you ever get really bad heartburn, like indigestion, which you may have got, that means your stomach acid is too acidic. And what you can do is you take one of these stomach tablets, over here, stomach tablet, which will neutralize that acid and make it not so acidic and hopefully relieve the heartburn. Stuff like baking soda, you probably know will react with vinegar if you ever mix the two together and they start bubbling and giving off a gas. So you probably know by now that an acid, something from here, will react with something from this side. Usually an acid and a base will generally react together. And just the last thing I'm going to say. Last thing I'm going to say today is looking at these two different types of acids, a strong acid and a weak acid. So like I said, an acid is something that has H plus ions, which you can get rid of. Something like HCl, which is hydrochloric acid, has an H in it. If they have lots of H pluses, it's a strong acid. And if it's got few, it's going to be called a weak acid. So stuff like hydrochloric, nitric, and sulfuric acids, all the stuff that we have around the laboratory that you definitely should not be drinking, they're all strong acids and do a lot of harm to you. Then it says ethanoic acid, which is vinegar. That's a weak acid. Inside up my milk, lactic acid, that's going to be a weak acid as well. These ones, they're going to have a lot less H plus ions. So are not going to be harmful to you. That's why we can drink this stuff. And that goes the same for bases. With a base, if it's strong, it's got lots of OH ions. And if it's weak, it's only got a few OH minus ions. Alright, we're just going to leave it at that today, and I am going to explain a couple of pages which I'd like you to do on this iPad. So we're just doing this page on page, over here, page 30. And yeah, just page 30. A lot of these are experiments which are coming up soon, which would be really cool. This one you actually can do at home if you've got red cabbage, tea, beetroot, turmeric, cranberry, goose, beaker. But really that's something I'd like to do at school at some point. So hopefully we'll be doing that soon. I'll be back at school next week. All I'd like you to do today is just page 30. Or if you are using the Scipad online, I would like you to do if you're using this book here, can you just do the indicators and pH scale section? Alright, that's all for me today, and hopefully we'll be back at school soon. There are no cases of COVID yesterday again, and might not be today, so we may be back soon enough. Alright, see you later.